System is a number system with a base of 16. This means it uses 16 different symbols, which are 0 to 9 and A to F, to represent numbers. The symbols 0 to 9 in hexadecimal are the same as the decimal counterparts. However, A to F represent 10 to 15 respectively. So, for example, if you have 13 apples in decimal, you would have D apples in hexadecimal. Hexadecimal number systems are widely used by computer system designers and programmers. Hexadecimal numbers are also used on web pages to set colors, as there are 256 different shades of red, green and blue that can be combined to create other colors. Each hexadecimal place has a value of 16 times the previous one. Similarly, decimal places are 10 times the previous decimal place. To convert the hexadecimal number into decimal, we need to understand this. For example, let's take A61. The first place value from the left is the 256th place, or A. The second is the 16 places where 6 is, and the last is the 1's place with the number 1. Using this method, we can see that A61 is in hexadecimal is equivalent to 256 in decimal, to 2657 decimal. Hexadecimal is highly interrelated with computing and binary systems, as its base is an exponent of 2. Due to this, a resultant property of hexadecimal is that each hexadecimal unit can be used to express 4 binary digits. For example, as you can see here, 10100110 in binary can be converted into A6 in hexadecimal, while 1010 is A and 0110 is 6.
Now we shall show you how to convert from hexadecimal to decimal. Suppose we want to convert 1A to B to decimals. So now we know that the value of the 1's place, which is 16 to the power of 0, is B times 16 to the power of 0, or the value of the 16th place is, which is 16 to the power of 1, is 2 to the power of 16 to the power of 1, while the value of the 256th place, which is 16 squared, is 8 times 16 squared, or the value of the 4096th place, which is 16 cubed, is 1 times 16 cubed. Hence, 1A2B in decimals is going to be equals to B times 16 to the power of 0 plus 2 times 16 to the power of 1 plus A times 16 to the power of 2 plus 1 times 16 cubed. And all this will be equal to B times 1 plus 2 times 16 plus A times 256 plus 4096 times 1 equals, and this will all be equal to 6699 in decimals. Hence, 1A2B in hexadecimal is equal to 6699 in decimals. Okay, so now we shall move on to converting decimals to hexadecimal. Suppose we want to convert 2000 to hexadecimal. Now we shall list out the powers of 16. 16 to the power of 0 is 1, 16 to the power of 1 is 16, 16 squared is 256, 16 cubed is equals to 4096. Now we see that 4096 here is bigger than 2000. So now we take the next biggest power of 16, which is 256, and we use it to divide. So 2000 divided by 256 is gonna be equals to 7 remainder 208. So now we know that in the 256th place is the number 7. And now the next biggest power of 16 is 16. So 208, which is the remainder from here, divided by 16 is equals to 13. And the remainder is going to be 0. So now we know that in the 16th place is the number 13, while for the rest of the digits, like 6 in the ones place, the value is going to be 0. So basically 13 in decimal form is also equals to D in hexadecimals. So 2000 in decimal form is equals to 7 from here, D, O, I mean 0, yeah, 0, as the ones place is going to be a 0. And this is in hexadecimal form. 2000 in decimal form is 7D0 in hexadecimal.
Following which, we shall now show you how to convert from hexadecimal to binary. If you remember, binary goes by the base 2. So 2 to the power of 4 is 16, and all values afterwards are multiples of 16. Suppose we have a hexadecimal number C26. Firstly, take the first digit. 6 times 16 to the power of 0 equals to 6. In binary, 6 is represented as 2 to the power of 1 plus 2 to the power of 2. Afterwards, we take the second digit, 2. So 2 to the times 16 to the power of 1 equals to 32, which is 2 to the power of 5. Finally, take the last digit, C, which is 12. So 12 times 16 to the power of 2 will be 12 times 256, which is 2 to the power of 8 times 2 to the power of 3 plus 2 to the power of 8 times 2 to the power of 2, which is equals to 2 to the power of 11 plus 2 to the power of 10. Therefore, C26 in binary is 110000100110, which is equals to 2 to the power of 1 plus 2 to the power of 2 plus 2 to the power of 5 plus 2 to the power of 10 plus 2 to the power of 11. After which, we shall show you how to convert from binary to hexadecimal. Firstly, each of the 4 numbers in binary number is one hexadecimal number. Suppose we want to convert 11101 to hexadecimal. We first look at the first 4 digits. Which is 1101. The first digit, 1, will be 1 times 2 to the power of 0, which is 1. The next digit, 0, will be 0 times 2 to the power of 1, which is 0. The third digit, 1, will be 1 times 2 to the power of 2, which equals to 4. And the fourth digit, 1, will be 1 times 2 to the power of 3, which is 8. So you just add them all out together, and you get the first digit of the hexadecimal number, which is 13, and in hexadecimal is D. So basically, you just take the digit and multiply it by the position of the digit subtracted by 1, and then add them all out together to get a digit in hexadecimal number. So for the remaining digit 1, you take it and you multiply it by the position of this digit subtracted by 1, which is 2 to the power of 0. So 1 times 2 to the power of 0, and you get 1. So therefore, you get the second digit of the hexadecimal number 1. So 11101 in binary is equals to 1D in hexadecimal number.
Now we shall move on to adding hexadecimal numbers together. So do you remember how to add in the decimal system, where you use long addition to add two different decimal numbers together? Well, it's about the same as for hexadecimal number system. Let's say you want to find out what is AF3 plus ABC. When you add decimals, you usually write one number on top of another, and then later you add the digits of the units digit of the first number of the units digit of the second number of the units digit and write it at the bottom. So the same goes for hexadecimal. So 3 plus C is going to be equals to F. F plus B is going to be equals to 1A. So because F plus B is equals to 1A, and 1A is more than F, so that's going to be a carryover of 1, and since the number on the 16th place, so A is going to be down here and 1 is going to be up there because of carryover. So now we just need to add A plus 1, which adds up to 15 in hexadecimal. So there you have it. In the end, you get AF3 plus ABC is equals to 15AF in hexadecimal.
Now, we shall move on to hexadecimal subtraction. Hexadecimal subtraction is similar to decimal subtraction, and similar methods can be employed, such as long subtraction. For example, take CA3 minus AD2. 3 minus 2 equals to 1, but A minus D equals to negative 3. Since the negative 3 is a negative number, we have to borrow 1 from the next digit, which is C. Then we add 16 to negative 3, which is 13 of course. Following which, C minus A minus the 1 we borrow equals to 1. Therefore, the answer to CA3 minus AD2 base 16 equals to 1D1 base 16. Remember that 13 equals to D. Now, let me tell you more about hexadecimal code and computers. Computers think it in binary code or base 2. However, that is hard for humans to read, so computer programmers use the hexadecimal code. For instance, to set a background color to green, I don't say green, I say, and the computer understands what I mean. Sometimes we put a number sign in front of the code, and sometimes we put an ampersand followed by H. It's kind of like talking to a friend in Pig Latin. Before you started, you might say to him, I'm going to talk in Pig Latin now, so he'll know what you're doing. For those who don't know, Pig Latin is a language game where words are altered slightly based on their first letters. Well, that's what we're doing when we put a number sign or ampersand followed by H in front of hexadecimal code. Since the computer doesn't normally speak hexadecimal, this is to allow the computer to recognize that we're trying to talk to it in hexadecimal code, figuratively. Now we've come to the end of our presentation. Thank you for listening, and we hope you have a better understanding of the hexadecimal number system after listening to it.